We will consider question 1. The height at which the acceleration due to gravity becomes g by 9, where g is equal to the acceleration due to gravity on the surface of the earth. In terms of r, the radius of the earth is 1, 2r, 2, r by root 2, 3, r by 2, 4, root 2r. For solving this question, what we required? So the variation of gravity with height. That's all. So g dash is how much? We got the equation gm by r plus h whole square. So this is acceleration due to gravity at height h. But we know g is equal to gm by r square. At the earth surface, g is gravity, acceleration due to gravity at the earth surface. So this implies that gm is equal to gr square. Substituting this in the equation 1, the value of gm, if we are substituting in the equation 1. So what we will get? G dash is equal to gr square divided by r plus h whole square. This can be written as g times of r by r plus h whole square. But g dash is given. G dash means gravity, acceleration due to gravity, acceleration due to gravity. At height h is given as g by 9. So substituting this value there, we will get g by 9 is equal to g times of r by r plus h whole square. So g will be cancelled, and we can find the square root of r by r plus h whole square. So we will get r by r plus h is equal to 1 by 3. This implies that 3r is equal to r plus h. So this implies that h is equal to 2r. So this option is given in h is equal to 2r. Option is given in the option 1. It is given. So option 1 is the right answer. So we will consider one more question. Question 2. A planet in a distant solar system is 10 times more massive than the Earth, and its radius is 10 times smaller. Given that the escape velocity from the Earth is 11 km per second, the escape velocity from the surface of the planet would be 1.1 km per second, 2 11 km per second, 3 110 km per second, fourth one 0.11 km per second. How to solve this problem? Escape velocity can be given by the expression Ve is equal to root gm by r. Ve is equal to root over gm by r. So for the earth we know, this is equal to, can be written as gme by re, and this is given as 11 km per second. For earth I am writing now. So earth we got this one. Next we have to write for planet. For planet, how much is this? Ve for planet is equal to root over gm by r. In the question, it is given 10 times more massive than the Earth and its radius is 10 times smaller. So we have to substitute the values of mass. So G is everywhere constant, 10 times of mass and 10 times smaller than R. That means R by 10. So how much it will become? 10 times mass of the Earth and this is the radius of the Earth. So this will become once again root GME by R E times of root 100. Root 100 means 10. So that is root GME by RE is known as 11 km per second multiplied with 10, that is equal to 110 km per second. The option is, so we got the escape velocity is from the surface of the planet, we got 110 km per second. That value is given in 3, so the 3 is the answer. We will solve another question, question number 3. See, this question contains statement 1 and statement 2. Of the 4 choices given after the statements, choose the one that best describes the 2 statements. Statement 1. For a mass M kept at the center of a cube of side A, the flux of gravitational field passing through its sides is 4 pi gm. If the direction of a field due to a point source is radial and its dependence on the distance r for the source is given as 1 by r square, its flux through a closed surface depends only on the strength of the source enclosed by the surface and not on the size or shape of the surface. Statement 1 is false, statement 2 is true, statement 1 is true, statement 2 is true, statement 2 is correct explanation for statement 1, statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1, statement 1 is true, statement 2 is false. So how to solve this problem? In the gravitational field, what is the formula for G? G is equal to Gm by R square. So R, we can also say field strength. Field strength is also G only R. So field strength is inversely proportional to square of the distance. In the second statement, it is given if the direction of a field due to a point source is radial. Yes, the gravitational field is towards radial only. And its dependence on the distance r for the source is given as 1 by r square. So this is right. Its flux through a closed surface depends only on the strength of the source enclosed by the surface and not on the size or shape of the surface. This is true. So you are getting the value also. Surface area multiplied with the field strength, you will get the value of flux. Flux of gravitational field, then it will be getting 4 pi gm. So it does not depend on the shape of the body or size of the body or size of the surface. So this is true and this is also true, and statement 2 is the correct explanation for statement 1. And even you can give the analogy with the help of analogy also you can make Gauss law in electrostatics. You can make the analogy electrostatics and you can solve this also. Now we will take another problem, question 4. If Ge and Gm are the accelerations due to gravity on the surface of the Earth and the Moon, respectively, and if Millikan's oil drop experiment could be performed on the two surfaces, one will find the ratio electronic charge on the Moon divided by electronic charge on the Earth to be A, 1, 2, 0, 3, Ge by Gm, 4, Gm by Ge. How to solve this problem? If we know the formula for Millikan's oil drop experiment for charge, we can solve this. Let us see the formula for charge. So according to Millikan's oil drop experiments, Millikan's oil drop experiment. Electronic charge is given by E is equal to 6 pi eta r divided by E. So here it is E is independent of G, acceleration due to gravity. So the ratio will be equal to 1. The ratio which is asked, that is electronic charge on the moon by electronic charge on the moon divided by electronic charge on the earth, is equal to 1. That means, so the option is 1.